Welcome to EDU World Space.
So here we have the problem 23.48. Question A is asking a complex that absorbs photons with an energy equal to 4 times 51 times 10 to the minus 19 joules. And the question is asking what is the wavelength of this photon? So what is the lambda? Alright, so the energy of the photon equal to this, and the energy is given, we're looking for wavelength. So the equation which relates the energy to wavelength is E equal to hc divided by lambda, where E is the energy of the radiation equal to 4.51 times 10 to the minus 19 joules. And H right here is the Planck constant. Planck's constant equal to 6 times 626 times 10 to the negative 34 joules second. And c is the velocity of light, and that is equal to 3 times 10 to the 8th meters per second. Alright, so we substitute these values into the equation and calculate for the energy for the wavelength of the photon. That will equal to hc divided by E. That is equal to 6 times 626 times 10 to the negative 34 joules second times 3 times 10 to the 8th meter per second divided by the energy, which is 4.51 times 10 to the negative 19 joules. So the units of joules and seconds are cancelled, and we remain the unit of meter, and we get a number of 4.41 times 10 to the negative 7 meters. And for the wavelength, we usually use that in nanometer. So if we convert that 4.41 times 10 to the minus 7 meters, convert that into nanometer, we get the number of 441 nanometer. Alright, so the answer for question A, the wavelength of the photon will be 441 nanometer. Alright, now look at question B. If this is the only place in the visible spectrum where the complex absorbs light, what color would you expect the complex to be? Alright, so here's the color wheel, and we know before that when a complex absorbs all the visible light except one color X, and then this color X is reflected, and this color X will be reflected back, and thus this is the unabsorbed color of the complex, and this is what we see. However, in this case, 441 is the only region that absorbs. So if a substance absorbs light toward this region, the color absorbed is toward the opposite or the complementary region. So 441 will be someplace near here, and the complementary region will be the opposite, will be about right there, right here. And this is the region that absorbs, and this is the color that we see. So since the complex ion absorb light of blue color, which is in the region of 430 to 490, so the color that we see of this complex will be an orange color. So that is the answer for part B.